In this video, we're going to be introducing how to use strings in C++. One important thing to note about strings is that this is our first standard template library container. So let's talk a little bit about what that means. So the standard template library has a lot of different components. We're going to be talking about a lot of them. The first thing to talk about are containers. These are data structures that can hold other things, that can hold elements. String is an example of a container. What does a string hold? It holds characters. There's also vectors, decks, maps, and many others. We'll talk about them later on in the course. The important thing to note about containers is the way that you use these containers is often by using an iterator. An iterator allows you to do things like loop over a container, or to access particular elements within that container, or as the result from using particular functions like find and things like that. And so the iterators provide a standardized way to interface with these containers. And one nice thing about iterators is that they're often what are provided to generic algorithms. So we're going to show you some of the algorithms today, but in future videos and future weeks, we'll talk about more of them as we teach you more about this standard template library. But there are algorithms that can take iterators and can use those iterators to, for instance, find a particular element in a container, or remove elements from a container, or count or sort them. So once again, in the STL, there are generally three things here. We have containers which hold other types of data generally. Most of them are they're called templated, meaning they can hold many different types of things. So you can have a container that can hold strings, or a container that can hold ints, or a container that can hold cars. You also have generic algorithms, which are algorithms that can take iterators from a container and can do this things like finding particular elements or filtering out all of the elements that meet a particular criteria. And these iterators are kind of the glue that allows containers and generic algorithms to talk to each other, so that a sort algorithm can work on both vectors and strings, things like that. So the string class specifically is used to represent a sequence of characters. And once again, hopefully everybody in this class is familiar with what a string is, and then you can pay attention to kind of the things that make strings special in C++. And so it's an example of an STL sequence, meaning, there's an ordered set of characters. And the important thing to note about it is that it has an example of, you have string objects, and each string has a certain set of operations that it can be used to perform with. The other thing to note is, unlike the fundamental types, string is not part of the C++ standard. It's part of the standard template library. Meaning, if you want to use strings, you need to include the string standard template library by saying include brackets string. All right, so what library is the standard template library string provided in? So I would accept either of the first two answers here. It's in the string library, but that string library is part of the standard template library. No, it's called the standard template library. The T there is important. It's not the standard library. There really isn't a standard library per se for C++. Okay, so the other thing to note is the string is our first example of a C++ object. Well, we've actually had some other C++ objects, but we haven't been thinking about them as such. Like cin and cout, those are actually standard template library objects as well, but we'll talk more about those guys later. But generally, when we're talking about objects, we care about two things. We care about what data it stores and what methods does that object provide for us to call. So in this first code example, we're going to show you a little bit about how to construct and use strings. Okay, so once again, in order to use the string, you have to say include string, and you need a prefix string with std, just like you would for using cout or endl or cin, string is part of the standard template library, so you have to prefix it with std : or, as is often the case, you would just use a using so that you can just write string in your code. Now, there's a bunch of different ways to construct a string, and here's an example of, I think, most of them. I know it's not all of them, but this is most of them. You can use curly braces to filled with characters to say, okay, I want to make a string with each of these characters. This is probably the most common way to initialize a string, is to use a string literal. This is a C-style string literal, with not really something we're going to talk about much in the class. The important thing to note is that when you have a string in double quotes, this isn't technically an STL string. And so what you almost always want to do whenever you're using any of these double quoted characters is you want to assign it to a string so that you can use it. Another way to create a string is to make a copy of an existing string. You can also use the default constructor where you don't fill the string with anything to begin with, and that gives you the empty string. You can also say, I want a string that's composed of 5 A's, so it's akin to saying my string starts off with this value. And you can also build a string out of another string and specifying the start index and how many characters from that string to copy. Or if you just provide one number, this is saying use this string, start at index 1 and go till the end of the string. Okay. The other things you can do with strings is you can index into them. Once again, this is something very similar to how Python works. You can index into a particular character. So right here, where last here is Simpson. If I'm doing bracket 1, that's going to get me the 1th character, because strings, just like in Python, are 0 index. So this would get me the 1. And if I do @3, it will get me the P. And now you might be going, hey, Josh, why is there a square bracket and an @ method? They seem to do the same thing. Well, when we get to the slides, I'll talk about how they're different. The other thing that's important to note is that using indexing, using the brackets or the @ method, you can assign values to change the string. And so I can say, hey, I want my 1th character to be an O, and I want my 0th character to be a T, and so we change Simpson to Thompson. The other thing to note is that the bracket notation will actually, and this is something different from in Python, you're allowed to reach past the end of the string, which is an error. It's undefined behavior. This is a very bad thing to do. And so when you're using bracket notation, you want to be really careful that you're not reaching past the end of the string. The big thing that makes it different from the @ method is the @ method would actually raise an error if you try reaching past the last character of the string. So here is in slide form what I kind of already showed you off in code. If you want to just make an empty string, you just say string, the name of the string. You can make const strings as well, just like, because you could put const in front of pretty much any data type. And this is saying, hey, I want a particular string that's initialized with the value tiger, but this string will never change. The other important thing to note is that just like in Python, strings are 0 indexed. The first character is index 0. The other thing to note is that each element of a string is a char. And so in this case, once again, a string is a sequence of char elements. And the nice thing about strings is they can hold a large number of individual characters, and they can hold a variable number of individual characters. Now, you can declare multiple strings just like you can declare multiple ints. This is saying make me an empty string and a string that's initialized with the value tiger. You can also do assignment to copy the value of this string into this string. And so the important things to note is, because assignment is a copy, what you have after this line are 2 separate strings that you can change independently of each other. The other thing to note is you can use curly brackets, which is an initializer list, to say what are the elements that are going to be provided. And because strings hold characters, these are each going to be individual characters, though this really isn't commonly written in this way. You can also initialize strings with a number and then a character that should be repeated that many times. The other thing to note about strings is that you can use the copy constructor to say, once again, if you have an existing string, you can copy it into this string. Once again, this equal sign here is saying copy this into this other string. Once again, it's important to note that these assignments, these initializations, are copies, meaning you have two strings after running this line. The other thing to note is that copying can be expensive. The whole reason C++ has references, well, not the whole reason, one of the important reasons C++ has references and pointers and things like that is because you're trying to avoid unnecessary duplications, unnecessary copies. And strings can be very large. You can hold the entire works of Shakespeare if you wanted in a single string, and then you want to be very careful about how often you have to make a copy of that string. And so once again, every time I say we're making copies, it's important to note for two reasons. One, you want to make sure that you know that if you change one version of that string, it's not going to change the other. Two, you've just dramatically increased the amount of memory that your program takes because it used to just have one string, but now there are two. The other thing I want to make sure we're all clear on is what a method is. So we've already talked about functions in this class. A method is a function that is connected to a particular instance of an object. It is usually the way that you refer to methods is you say the name of the instance of an object dot the name of the method and then parentheses any arguments that that function may require in its invocation. So there are a couple different methods that strings have. Actually, no, more than a couple. There are many different methods that strings have. On this slide, we're talking about two of them. Size returns the number of characters in a string. So if I say the name of the string dot size open close parentheses, this will tell me how many characters are in that string. And so if my string is tiger, there are 5 characters in that string. Strings also have a length method that gives that's the exact same thing as size. Now, if you want to access individual characters in the string, you can use the @ method, which will say it takes a given index and it will return the character stored at that position. You can also use the square bracket notation to do much the same thing. Now, there's one important difference between using the square brackets and the .at is that the @ method will throw an error if you try reaching for an illegal index, whereas the square bracket will not. It is undefined behavior to try to access characters that aren't part of the string by giving, for instance, too large of an index. The other thing, which hopefully everybody here is comfortable with, is that just like all sequences in C++, strings start indexing at 0. So if you aren't comfortable with 0-based indexing, make sure that you're comfortable with the fact that the first character in a string is at position 0, not position 1. The other important thing to note is that when you're accessing a index using square brackets or the @ method, you can assign characters into those positions by just using the assignment, by just using the equal sign. This is saying put a J in the first position of this string, or put an H in the first position of this string. And what this does is it, once again, changes the string to have different characters than it did before. This is quite different from Python, where Python strings are immutable. You can't change a string after it's created, but in C++, you're allowed to mutate. You're allowed to change strings by using, for instance, the indexing operators. Unless, of course, you put like a const here. If you put a const string, then you won't be allowed to assign into a string. Another way to change strings is to use the assign method. So let's walk through what's happening here. Here we're making an empty string called a string. We're assigning to it this 5-letter string to a string. Here we have a string called next string, which once again defaults to empty. And here we're assigning it a string starting at position 2 and going until the end of a string. This string NPOS means go till the end of the string. We'll talk more about this in the next video. And what this says is basically copy this string, but starting at position 2, going till the end of this string. And this is another way to fill next string, to assign next string a particular value.